I'm trying to call you, but it's not working, so maybe you need to turn your phone back on. What is up, YouTube? It's Cord Campbell here today. Back again, working on documentation today. And we might have a guest joining us, maybe. I'm hoping a guest is going to be joining us here shortly. I'm the current viewer, so there's only one viewer, so we know that he's not looking at it yet. But we're going to get going here just shortly. There he is. All right. Hello. How are you? Yeah, I believe it. I figured as much. Yeah. Oh, that's fine. We've got a backup plan here, so always have a backup plan when you're doing demos. So uh, I'm gonna talk through what we were doing while you were rebooting there. Okay. So what we did is we had essentially we have two ways of remembering a page, and when we remember the page, we're just talking about URLs right now, like web pages. But we could also do this with images. So we have an image uploader that we can use as well. I'm going to use the word we. I'm not trying to indicate that. I mean, if you want to be part of this, you're part of it. So that's just assumed. But I'm using we because I'm streaming now. So I'm actually on stream now. So I'm using we. So but we also have a way to upload regular images, like I showed earlier of Zen and I. So we can upload a regular image as well, which I'm doing with the APIs right now. But I need to work on the UI component a little bit to get that working, and then I need to hook up the bits for getting the imagery being passed to Google Vision. Now I'm going to talk a little bit about the models here in a minute, the network models, which is, if you remember when I was talking about my mom being animated from that static image. So what the models can do now is look at a picture, and then they can infer a 3D model from the image. So these models have been trained on a bunch of faces, and then they've been shown a bunch of 3D models of heads, for example, and eyes and mouths and stuff like that. And so they're able to recreate, by looking at an image, they're able to go into the model and pull out information that's in the model to build a 3D model. And then it's just mapping the text, the texture it has of my mom's face that I uploaded onto that model. So even though it looks like her, it's like the model's built off of a bunch of people. And these models contain data, so that you can kind of imagine them like a database. They in a real way, these network models are a database. That's sort of how our minds work as well. But what we did is we uploaded a picture of a website to it, and then we had a model which is good at reading text, look at the page, look at the picture of the website, and then that model then extracted all the text for us. So then we were able to, give it the picture of this website, which was called physics.org, and then the article "Warp Barrier Faster Than Light" was then read by the system, and then all the text was pulled out, and then we have the text for it. Just sort of like it pulled out the text on my coat and read it was Patagonia, right? So if we have a search engine like Solr, we can take the result, timestamp it, and put it inside of Solr so that we can search for things later. And what I was doing with you when the screen went black on the Zoom was I was going to show you how we can now search for, because we've indexed that page's words that the model returned to us. It's kind of like my mom's eyes are blue in that model. Like it's not real obvious in the picture that I uploaded of her that her eyes are blue, but it's sort of, it does something weird with eyes. It like builds an extra model with eyes. It has some textures it uses with that. It made her eyes blue, and her eyes are blue, so that worked. But in in our case, what we're going to do is we're going to look for things like we're going to look for things that are on the page, like let's see here. Let me go look at the actual. I don't want to search for something that's in the title or description because that's kind of cheating. But it says looks like spacecraft is on the page. So if we go in and we search in the UI, in the Mitta UI for spacecraft, then what's going to happen is that page is going to come back. That record is going to come back, even though that wasn't in the title or the description. It still came back because the model saw the word spacecraft on the page. Does that make sense? Okay. Yeah. You can go into your email and click on the YouTube link I sent you. And there's you should see my YouTube, and then you should see episode 30, Code and Law. Might be up at the top, says live. Click on. Oh, well, I didn't update the thumbnail. Yeah, I didn't update the thumbnails haven't been updated. Yes, click on episode 30, Code and Law. And I should see you pop in the stream here in a second. Yeah, I think your internet's a little challenged there, but oh wow. It's like things have fallen apart a little bit, for sure. I hate to see, a zombie outbreak. I think internet might suffer from a zombie outbreak is my opinion, but so you see me now. Okay, good. Yeah. Yeah, well, I mean, you should see something that okay, good. Oh, I have 2 concurrent viewers. Now, if you would just mute me, that'd be great, and I'll just keep talking to you on the phone. So if you could just mute your computer, hit that key on your keyboard to mute me. That's perfect. Okay, great. Great. So and holler at me if you don't see me moving around and stuff. So here we are back on the page that we searched, that we did earlier. This is what you saw me working on earlier, and here I did the search. And I did a full text search for spacecraft. And I don't believe the word spacecraft is in here, but we can look. So let me just scan this page real quick and see if I can find spacecraft on it. So you can see spacecraft does not occur in this text here that I have highlighted, correct? And the reason why it still returned a record, so let's just type something else just to make sure I'm not faking it, right? So that's not matching a search, but if I search for spacecraft, then this page comes up. And the reason why is because if we go and look at the image of it, the word spacecraft occurs down here at the bottom. And there it is right there. You can see it right there. I can't highlight it because this is a picture now. It's just a picture of a page. There's not any HTML. I can't highlight things. I can't click on stuff, right? If I click, it just does this, right? So I've turned the page into an image, and so but now I sent the image to a model. So the idea here is that once we have the images of the pages, we can send them to the models. We can send them to a variety of models. All right. Yeah, sure. Pick a word. Fission reactors. Okay, so I'm going to search for fission reactor. Now that might be up here. So we're going to look. What? Yeah, so we can see here that there's no fission on the page because I just searched for it on the page, right? So now what I'm going to search for full text because that's the field name, fission reactor, and there's the result. So I'm going to clear the page and we'll do it again. Right, there's the page. Right. And actually, we could search. You can see the Staples ad right there if you squint. Right, you can see where it says Staples right there. Well, you can click that little square down to the bottom right, and it'll make it bigger. And then make sure you, yeah. Okay, now you can be sure and like, subscribe, and follow, and click that notification bell to get notifications of future videos. I just ran an ad. That was an ad for everybody. So, and I just searched for Staples, and there that popped up, right? And the reason why, maybe I could search for 30% off. Yeah, that works too. Oh, well, actually, I got another one because this one evidently has an ad that says 30% off as well. So I have another article here that I've indexed, and this one must say 30% off somewhere on it as well. Maybe. Somewhere in here. This is another article that popped up that I had indexed as well. So maybe there's an ad on here that says 30% off. I don't know. I'm just looking real quick. But this is an ad on Elon Musk. Let's see. Founded startup OpenAI discovers artificial neuron only ever seen in the human brain. And it found a multinodal neuron, evidently they found that, and that it responds to an image of a spider, an image of the text spider, and the comic book character Spider-Man. And they're calling it the Spider-Man neuron. I can't make this stuff up. So if we search full text for Spider-Man, then we're going to get that article. You can see it there. Now, we have an uploader, which I cannot demo for you, but this is what it looks like. And if I click here, normally what happens is I can select images. And when I do that, this represents a spool, just like the one for the web pages. So if we look at the spool earlier, and I apologize for scrolling past all this text, I'm just trying to get back to it quickly here so we can see what I'm talking about. But we can see the spool coming back here. This one's called Free Ultramarine Monkey. And this is the one for Google News. And it has two file names. Well, in the case of, let's say you wanted to upload a bunch of pictures of a topo map. Okay, so you uploaded 100 pictures of a particular topo map. So you sliced it up and you uploaded all of them. And then you passed it to a model that knew how to find things on a topo map. Then what I'm going to do is I'm going to provide you a way to search for those particular, and we're just going to pretend here, right? Topo map thing field, right? Whatever topo map field, like maybe we're talking about depth, right? Depth here. So like a well depth. Then I would type in, 1,000 feet or something like that. And I'd hit enter. And then what would happen is if you had a model that was trained on finding things that were 1,000 feet, I'm just making up some arbitrary thing here to talk about. But it would then return those documents that had discovered that it had a depth of 1,000 feet or more in that particular image, and it would return those images to you. So it's a way for everyday normal people to take any type of machine learning model that exists today and let you upload the documents and imagery. And if you want, we'll crawl it for you. So we'll go image the website for you so that you don't have to go do that yourself. We have a little button even, so if you wanted to go over and for example, here we're looking at Elon Musk's explaining why Starship prototype exploded because it caught on fire. We can actually click this little icon that we've got, and it'll grab the page for us, and it's telling me I need to log in, but it'll grab the page for us and then it'll upload it to Mitta right from your browser. So instead of me making a copy of the web page, it lets you make a copy of it. So if you wanted to copy something that was proprietary, or you were logged into some view, if that makes sense, if you were logged in on your computer to your email or something and you wanted to take a picture of your email, then you could do that using this plugin that I have for Chrome that I've written. I wrote part of it. I didn't write the whole thing, but I wrote part of it. Yep. Yeah, there will be, because we're live on, yeah, I'm sorry about that. Sure. Right. 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 We could train it to do that, yes. So it could, so what happens is, what Apple is doing, so the question is, can you take a family member, can you take a bunch of photos of a family member and upload them to this and have it tag them or identify them as a photo of a family member? So something that's specific to you. And the answer is yes, you could do that. We could build a model that learns people's faces just like Apple has done. This is fairly standard stuff anymore, surprisingly enough. So Apple does it, Facebook does it, I think Instagram does it because that's Facebook. So there's a lot of photo sharing sites now that will, I think that Google stuff does it as well. Google Photos, I think, does it. So we could enable that to do that, but this is, I mean, because we're storing web pages here, this is, it could do that. In other words, it could operate as a photo storage system for you. It will operate that way. You would be able to use it like that, yes. No. Mm-hmm. Yeah, so if, and you're going to have a little bit of delay here, but what I'm going to do right now is I'm going to tell it to go look at my Twitter page. So I'm just typing in my Twitter account, and then I'm going to hit enter, and it's going to go grab it, and it's going to index it, and it's going to take a picture of it, and then it's going to return it to me. So it could be used for research for sure. So it could be. I was talking to a realtor friend of mine down in Austin, that and she was talking about she was asking me, could I use this for real estate research? And I said you could absolutely use this for real estate research, because you could go in and you could say, from a text standpoint, and we've been talking about indexing text because it's a search engine for text, but she could go in and she could save a page, or she could make a clipping of a page, and she could say, I like this page a lot, I want to save this, and I want to be able to find it later. But because it goes out and hits the internet, it's taking a picture of what's on the page. So we could tell it, for example, to go to your daughter's Instagram account, just like I did with my Twitter account here, and it could image that and return that as a document for the insurance agent. It's a document that they're creating that it's technically now an enterprise document system that is using machine learning to discover something. They could have trained it on her photo. They could go into this page and they could say, well, this is the person in question here, who, and in my case, it's upside down obviously for a reason. But like we can see another picture over here of me, which is a little bit smaller, sailing. And I could go in here and I could say, well, I want you to take this picture, this sub picture on this page. In other words, the system could turn this into a document. So they could go and extract, they could go extract your daughter's image, and then they could say, okay, now go look on a bunch of pages and see if she's appearing on those pages. But the amount of training that would be required for that, they need a lot of pictures of your daughter in order to identify her on a page. It'd be much easier for them to say, oh, well, she's put her name, Sarah Smith, on this page, and now they're monitoring this page because they know she's a client or a customer who's made a claim. They could go and look at that, and then the human could say, well, I think that she's doing something. But to make the computer do it, it might be a little bit more challenging, but the human is still doing the research. So the human would use it to, basically the human would use this to archive her social media page, but not necessarily detect that she was doing something on it. The human would be the one responsible for reporting what she was doing on the page, for example. Yeah. So one of the areas that we've identified in poking around on this software, the idea of this system that I'm building is research. So any type of research that needs to be done, if you just want to quickly move through things, and I'm just going to give an example here. I'm going to go to Google and I'm going to click on a bunch of these links. And again, you're going to kind of see this animate in over time. But I'm going to go in here and I've got three pages popped up, and I'm just going to go in and I'm going to save them all really quickly. And I'm going to do it in a couple of different ways. Number one, I'm going to go to the page and tell it to crawl it. And the other one, I'm just going to click on it. And I'm just going to click on two of these like that. And now I've imaged these pages. So I've just imaged 3 pages. And I've done that in rapid succession on these pages, and now they're all stored in the system. And so if I want to go and, for example, search for this one where the DC area forecast spring fever, if I want to search for the, for example, the title spring, then I'll pull back that article. It'll come back to me. So I'm able to save things very fast and very, very rapidly, and I can also narrow by time when they were looked at. And the key here is not only when the user is saving the imagery, the human is saving the imagery, and the human is sending URLs for crawling. We're saving that by time, but we're also saving what the models, the AI is doing over time. So the AI could look at it later and say, oh, well, I see a bunch of words on this page, this article on the forecast of Washington's weather. I see a bunch of words on this page. Well, I'm going to pull those out right now and make those searchable. But then maybe in 30 minutes it goes and it says, well, I've analyzed this document and I've discovered that there's a picture right here. And I'm going to take the picture out and create a new document. And I'm going to look in this picture and I discovered there's a horse and a man and a sunset here. And I'm going to create a new document called Horse Man Sunset. And I'm going to index that, and if the user ever searches for horse sunset, it'll show this picture and the time at which it occurred, when it discovered that, when it actually looked at it. And that's how you work. So I'm going to tell you a little story I told my mom this morning. So I had this, have you ever eaten spun honey? You know what I'm talking about, spun honey? They whip it up and they put it in a container like butter. Well, I bought some and I ate all of it. And then I had the container, and I was like, I might use this container for something. And so I washed it and I put it in the cabinet. And then a couple days ago, I needed to go somewhere and take sour cream with me to go eat go have a picnic. And so I pulled out the spun honey container, I put sour cream in there, and I went and had my picnic with my homemade chili. And I ate it, and I ate the sour cream, and I came home and I threw the container in the sink. And then the next day, I put water in it so that I could wash it out, and I put the lid back on. And then the next morning, I got up and I was like, oh, I need to wash that. So I washed it and I shook it around, and I made my coffee, and I went off into my office, and I came back when my coffee was ready, and I got my mug out and I put milk in it, and then I was like, I opened the cabinet and I started looking for spun honey, and I don't have any. I ate it all a while ago, and I have this big container, honey bear though, of honey, and I looked at it and I'm like, no, I want the spun honey. And I was looking, I was like, where the hell is the spun honey? And then all of a sudden my mind popped on and said, you don't have any spun honey, you're just looking for it because you held the container earlier. And I had put it in the recycle bin, and so I actually reached down and pulled it out of the recycle bin and set it on the counter to keep it. And that's how our minds work, is that we work on imagery over time. We work on concepts over time, and we work on audio over time. And so that's what we're building here, is a way for these machine learning libraries to remember what they saw in the order that they saw it. Right now, we're just showing things to models and saying, hey, is there cancer in this image? And then the model goes, I think there's cancer in the image. And then the human says, great, I'll see you later, and turns the model off, and it goes on its way. But what we're doing here with this thing is we're giving humans a way to start adding data to a system that then a machine learning model can interact with over time to learn about things that might be interesting to the human. And in your example, you're like, well, could it learn that my daughter Sarah is in a photo? And I'm like, yeah, it could, but that in and of itself, it really isn't very interesting, because sometimes it might look at the photo and not think it's Sarah, and sometimes it might think it's Bob, right? But if we could make it remember over time that it had made mistakes and things like that, then it could start being more interesting. So the way that we put this at work when I started thinking about this was that it's like a memory system for the machines. So we have AI doing things that we do with our mind. Like my mind, when it thought, I need to look for honey, I just offloaded that process to my visual consciousness. And my visual consciousness started looking for spun honey, because it had been primed with a spun honey container. Well, I tried to go find it, but I didn't have any, right? Like it wasn't able to match. So then an exception occurred, which is, where's the spun honey? And it's like, I didn't find any spun honey. I found a honey container that says spun honey, and I also had honey, which is what I ended up using, honey, right? But then I became aware of the exception and also why it occurred. It occurred because I had seen it earlier. So that's what we want to do, is we want to build a system that allows people to have the machines that they're interacting with to remember those conversations over time. So at its very core, if we look at the interface, we're interacting with a search index, but it is an AI entity of a sort that I call a sidekick. And the sidekick is your personal search assistant. So instead of, in the future, if we can make this work, we're competing with Google. So Google is our competitor. So we're going to replace Google with this. We're going to replace Google with an AI agent that will go search for things that are important to you. That's the upshot of this. So it's not just photos, it's everything. If you want a good restaurant, if you want to figure out how to get somewhere, it's everything that Google has done so far, it's rethought it into an agent that can talk to you. And the thing is that the reality is I'll probably never be able to get that manifest, but it's at least is where I'm going with it. And at some point somebody will go, oh, well, this is probably somewhat useful to us, so we'll buy it from you or something. I don't know what I'm going to do with it, right? But Good. Right. Right. Yes. It is. It. Exactly. It is a augmentation to your memory that it will eventually learn from you and become intelligent like you in a way, intelligent like you enough that it can help you find the things that you need to find and to learn the things that are helpful for you to learn to be a better human, to be happier, to, enjoy what is provided as being, you know, right. Right, recommendation systems, yeah. Hmm. That's just a fragment of it. That's correct. It, right. I mean, that's exactly right. I mean, it initially it looks like it's just a bookmarking site, or when I did grub, and this command is actually called grub because I did grub, and there's no copyright on it anymore. It's gone because it's not being used. The reason I called the command grub is because it's like a crawl, but it's not really a crawl. It's an image. I'm creating an image of the website. But we're using a tool that's for testing, which is called Selenium. We're using a tool for testing to a web page, but then we're, instead of testing the page, we're just taking a picture of the page and saving it. But then the other that, which is very grub-like, that's sort of what grub did, except grub would remember the HTML of the page, not the actual page itself. But HTML and pages are it's just a rat's nest. If we were to look at say one of these articles that we pulled up, if we were to look at the page source is just a rat's nest of crap. And in some cases, the text that's on the page doesn't actually occur in the HTML anymore. People have made it to where pages are now dynamically generated, and there's not really a good way to tell what a page actually says from page to page. There's no standardized way of understanding the text on the page as it correlates to the HTML. So by taking a picture of it like a human would do when the human looks at it, we're able to save that aspect of it. But that's just one part of understanding what the page is about. Another part of it is actually understanding what the page says. Another part of it is training a network to take the pictures that are on the page, which nothing does this today. I cannot find a piece of software that is designed to extract from an image of a web page the sub images that are on the page. And if you could do that, then all of a sudden now you have a whole world open up to the AI, to the machine learning models. They could look at pages. They could say, well, I'd like to know something about, Elon Musk. And then you're all of a sudden you're like, well, that's great. Here's a page on Elon Musk. Well, here's a bunch of text. That's nice. Well, I'd actually like to see some pictures that are related to that text. And all of a sudden you have two people sitting on their truck looking at a rocket. And now you have so much better idea. A picture's worth 1,000 words, right? You have a much better idea of what's going on with the content that you're looking at. And from those, as you saw with my mom, if you can give the computer a picture of it, all of a sudden now you could render a 3D scene of what these people are looking at while you're telling the story from the text that's on the page. And the experience changes about how you learn stuff. Instead of being assaulted with this video we see over here of garbage coming out of something and oil derricks running, right? We actually see something that is more pertinent to what we want, but we're going to have to pay for it. It's going to have to be. Right now, all the content on the web is monetized by advertising, but then that model is flawed. I don't want to see a bunch of ads. I want to see the data that's interesting to me, and I want my AI to get the data that's interesting to it, that it can help me do what it needs to do. Very specific to you, trained to you. Yeah, trained to you, yeah. You know, there's a larger existential problem here, which is if we continue to go down the advertising model route, that's very competitive. If we create AI that's monetized from models that are like advertising models, we're going to end up with an AI that's independent of us in a very real way. It's going to be, you know, if you've seen The Social Dilemma, it's sort of like that. As opposed to an integrated solution, which is more about, let's train an AI for you, Rick. Let's give you, you know, your sidekick that's important to you, that it'll go out and it'll just save data that you're interested in, and then later on it'll be trained to understand more about what you want, and it'll be your assistant, if you will. It'll be your sidekick in helping you find things. And we could maybe move away. You'll have to pay for it. It has to be monetized somehow, so you're going to have to write a check to use it, right? That's right. That's right. Yeah, that's right. Yeah, it saves you time by not having to look at the advertising and find the stuff. Yeah. Right. Fuck the ads. That's exactly where I started with all of this. Like, I just got sick of the advertising. And right now I'm proposing it's like $8 a month. With this, what I have here, where you store about 400 gigabytes of images, which isn't a lot, but it's enough that an average user that's just, again, if we just look at the kind of research component, we go after my friend Nikki's use case, which is she's a real estate agent. We just say that's kind of the market we're going to kind of play in for a bit, and we're going to see how that works. Then she starts saving a bunch of pages. Maybe we'll learn about the real estate market. She gets a little real estate bot that can talk to her when she needs to query it. She can talk to it on her phone, or she can talk to it in Slack, in chat, or she can get on the web and query it. And she pays about $8 a month. So that's about, whatever that works out to, about $100 a year, right? She's paying $100 a year for this service. That's about Amazon Prime. People pay $100 a year for Amazon Prime now. So it seems to me that it's worth it. Right. Right. You're not having to try to remember. Hmm. Right. Yeah. Yeah. Well, Google has indexed everything, and that was my argument at this last gig that I was doing on contract, was that we assume that Google is superior in providing this function, but their revenue model is advertising, and they've indexed everything. Yes, they enable digital hoarding. They're a digital hoarder. That's correct. They've ingested just about everything. Yeah, and honestly, they don't ingest the things that are they've built services to ingest things like email. So the reason Gmail exists is because they couldn't index your email, so they just provided you email so they could index it. They try to be good about that, but then the thing is if you have private documents on your desktop, or you have it in a system you're accessing via the web, you have to be logged in. They don't have a way to get to that, and this does, and it should, because I keep all this private. All of this stuff is 100% private. None of this images you upload to the site are shared with anybody. There's no ads. There's tracking code or anything like that. Yep. 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 You will be able to limit like temporary tokens to look at the data to other users. So you could create basically an index that could be shared between a couple of users. Yes. So sort of like Dropbox does a little bit. And they would be able to search that index like you do. So you would be able to create the imagery, you would be able to upload it, it could be auto tagged by the machine learning libraries, and then people could come in and look at it. It's a basic, that's an enterprise document feature, is sharing, ACLs. So I have implemented ACLs in the system, so there's a way to limit the access of who looks at it. But it can't be made public, however. So yeah, I mean, it's not designed to be a publicly shared thing. So it's not like a social media service. Mm-hmm. Yep. You're able to, right. My assertion was I've done search for over 25 years, on and off. So even at Zoto, we did search. And the uh, the thing that about it is that the larger the so it serves Google's purposes to have a very large data set, and the reason why is because their model is based on advertising. But in the case of which is ever growing, so like advertising encourages you to do things that you weren't doing before, or buy things you hadn't bought before. It could also serve a purpose of having you buy something you need, but nevertheless, it's typically trying to get you to consume more. But in the case of Google, it has all of this content. So some of it, if you want to learn something, I mean, Google's a great resource for that, and they're able to monetize that service they're giving you by providing advertising. So there's intrinsically, that's not necessarily a horrible problem. It's just that they also fall down at being able to index stuff that you might want no one to look at. So if you have a bunch of images and you want to say, for example, for whatever reason you want to remember, like what we're looking at here, you want to remember every image that has a bicycle in it. Well, there's no one that does that for you right now. And B, Google could not look at those documents unless you wanted to make them public or put them out there in the open, like basically in a service that they provide for you. You couldn't do it. They don't even do that on Google Photos. They don't show you photos with bicycles in them. So you wouldn't be able to do that, and that's a very simplistic example, but you wouldn't be able to even do that because they don't even have the data in that huge set of data that they have. That data doesn't exist. So use, yeah. Hmm. Right. So I just did a Google search, which thank you Google. But it's estimated globally the document management services globally are estimated to reach $57 billion a year by 2027, and the growth rate of that annually is 7%, which isn't a lot right now. But if we look at the growth rate for AI and machine learning applications, the growth rate is about 40% right now. And I think it's expected to grow, let's see here, machine learning market. Yeah, well, you would expect that, yeah, for sure. Machine learning market to grow to US 11 billion during 2024. So and I don't know if that's worldwide or not. I guess it's worldwide. So it's 11. So machine learning is already $11 billion a year. But yeah. Hmm. Yeah. So what's going to keep other people from, like, what is, so what the kind of the question would be rephrased would be, what is the competitive advantage or the barriers to entry to other competitors on this? One thing I would indicate is that in a market of a significant growth rate, typically it's when you're looking at green fields, like it's kind of like the Oklahoma land rush. Yes, you were competing against other people, but there's enough resources or enough green field that if you're early, you're going to get some of the field. So there's that. Right, that's not always a great reason when you're looking at a 7% growth rate. It's competitive. I'll give you a good example of that. I've been looking for a house to flip, and you just can't find one in California. You have to go way out in the boonies to find a house to flip. And the reason why is because everybody here wants to flip houses, so they've all got figured out ways to get to the houses that need flipping. So all the houses that are on the market are all finished, right? They're already been flipped. So in the market that we're talking about here, how we would compete against people would be we would just be innovative. We'd have to innovate in the right way, and we would have to find the right market, that the early market that would grow us into a larger opportunity. So the larger opportunity, I would say, in this particular situation, we're applying search to machine learning. And the way that we're doing that is we're going back to the square one and tackling a problem, which is privacy and search. So people are having a hard time, in general, people have a hard time, not everybody, but some people have a hard time when they're looking at a lot of information online like you and I do, having a hard time going back and finding it later. So we can use bookmarks. There's a whole bunch of free offerings for it, but those offerings, because they're not being monetized correctly, and I say monetized correctly, like Chrome used to have full text indexing for the pages you would look at. So like this page I'm looking at today, right here, used to, if I bookmarked this in Chrome, it would index the whole page for me and make it searchable. They took that feature out of Chrome and decided they weren't going to work on it anymore. And the Chrome is free. So if you look at Google, if you go to Google and look at it, and you type in something to try to find this page again, well, they're going to give you a bunch of ads at the top. So you're already starting to be disadvantaged in finding it. But if you already looked at it, you have a right to go back and find it again. That's just fair use. So it seems to me that the companies that are in the space already have a desire to continue to compete in the markets they're already competing in with their search offerings. But if we look at new market emergence, the new markets may open up that they don't yet realize because they're large. It's the 800-pound gorilla problem. Sometimes 800-pound gorillas don't realize there's a new market opening up. They miss it because they're too big. Their movements are too coarse. So by being a small, nimble startup, you can find those. But the key is going to be just iterating on it. Like we make an assertion or a hypothesis like I have, write some software to solve it, have to have the right disciplines to know how to do it and understand the technology. And then we go after a small subset of the market, research, for example. So researching real estate, researching science, researching, psychology, researching social media abuse, reporters could use it. So we're tackling a root of a problem in our society, which is information overload or fake news overload, if you will. A lot of the news that's out there is not, I hate to use the word fake news, but it's inflated news. They're trying to get people to come in and read these articles and then click on the ads. Sensationalized, yeah. So it's not accurate necessarily, it's not inaccurate necessarily either, but it's just there for entertainment purposes. But if you actually have people that are trying to get stuff done and try to find the actual truth of the matter, then this is a good tool for it because you're allowing them to create a smaller data set. So I think it's that the key is creating those smaller data sets, not the whole internet, not the hoarder's delight that is Google, but a smaller data set of targeted information that people are able to then search and interact with. There are sites who certainly aggregate links, like Reddit, Hacker News, Slashdot. There are even more private sites like forums, like Trey used to run, that they will share links and URLs and stuff. But those are all private to them, the people, the community. You want to create something that people can create, or actually, maybe a better way to put it is, at last, we're giving the search technology to the end user. As opposed to going to Home Depot and using Home Depot's search. Home Depot uses the exact same search engine that I am. So if we go to Home Depot and we go and look at them and they have a little search box at the top, that search box is actually powered by solar. And if you type in something like nuts, and they return a bunch of nuts for you, then it uses solar to do all of that. But then you don't have access to the functionality that solar has here because they're using it the way they want you to use it. They're going to monetize it the best way they can because it's their search engine. In our case, what we're talking about is actually allowing the user to unlock the full potential of the search engine through a UI that allows them to do that. And that's never been done before. Search is not available to end users right now. That's what I wanted to change that. I wanted to give it into the hands of the end user. But anyway, that was sort of the whole shtick with Grub. Is back when we did Grub, and that was a long time ago. 20 years, almost 20 years ago we started working on it. It was 20 years ago we started working on it. We wanted to be able to allow people to submit their own content into the engine and then search it. And we didn't have a search engine to put it in back then. Now we do with Solar, we do. But we wanted to give it into the power of the people. And now we have a way to actually create a new type of crawler, which is human powered. The humans are collecting the data as opposed to the machines. So it allows us to create a more targeted data set that we can index. And with that targeted data set, we could train these models to do all sorts of interesting things with that. They could extract images, they could analyze text usage, they could infer sites or content or search terms for the user that the user could then use with Google to go look at the hoarder's delight and actually search for things better in Google with the stuff that they've already saved. Yeah. That's That's a great analogy. You right to the nut of the problem. Yeah, the shotgun versus the shotgun versus the sniper approach, or the tight focus. Like, narrow the focus down, limit the data set, allow the user to create the data set, and augment it. We can augment some search terms for the user. We can augment with some content from other sources like Google. People are drawn to an image, that's correct. That's right. That's what people are primarily visual. That's why we have eyeballs, for sure. 100%. I love it. Well, I appreciate you listening. Your self-deprecation is always amusing. That's just because hubris is a thing, so, you have a way to. I always find you're extremely intelligent. You understand things on a different level than most people do, so. Yeah, I'm with you. Can I put you on stream saying this? Is it okay? Can I? Okay. All right. Everybody, this is Rick.
Henry Ford would never have any success at all had he not had access at the exact or within a 5-year window of wire and magnetos and gasoline and all the components that were out there. But what he saw was, there's all this shit out there, but all I need are 10 of these items to build the internal combustion engine, and they all exist.
Oh yeah. And
it changed the world for 100 years.
Right.
And that's really all you're doing, is there are all these pieces out there that you don't need all of them, but you've identified the ones that you're interested in.
Yeah.
To build this sniper approach.
Right.
And it wouldn't be possible for you to be a sniper if Google weren't built.
That's right. Yeah, that's exactly right. If we didn't have the dumpster fire,
we didn't have all the clunky shit out there.
Yeah.
You couldn't even have this idea.
No, that's right. You'd have no way to go and find the content like that. There is a source discovery, which is you have to go out and look around.
Yeah. Well, let's go back 30 years. I need a flight wheel for my Briggs & Stratton 501 engine. Well, there's a million of those out there.
Right.
Well, where in the fuck am I going to find it? Okay.
Right.
Well, now you just get on Google or eBay, and away you go. You got 500 of them.
Yeah, that's right.
We used to do it through garage sales, but you had to do a lot of driving around to get lucky.
Yeah, that's right. You got to do a bunch of crawling to find it.
Yeah.
Yep.
Yeah. First generation crawling.
Right. That's right.
Okay. Let me think about this. Okay.
Okay, man. I appreciate your time.
And thank you for your time. And This is fascinating. Well, just give me a little time to try and halfway catch it up with you.
Okay. All right, man. I'll talk to you soon, all right?
Adios.
Adios.
Bye-bye.
Bye. All right. So that's great. We had a new viewer today, and well, on air guest, I should say, Rick, my friend Rick, my longtime, very dear friend Rick. So this is a little bit of an odd episode, but we've been running an hour. I'm just going to end it there. I think that was a good maybe demo slash like discussion for what we can do with this. I haven't been spending a lot of time thinking about taking this to market, but I've have a few calls this month regarding that, and I need to be thinking about it, and this has helped immensely with it, so I do very much appreciate that. So I'm going to end the stream and probably rename the stream or something. I'll figure that out later, and then we'll pop back in today here in about an hour, and we're going to take a look at fixing the documentation and see if we can get this uploader tool fixed this week and get the Google Vision AI machine learning object library running on it, and go from there. So thank you for joining us, and if you liked the show, be sure and give it a thumbs up and subscribe. I'll see you soon. I'm Cord Campbell, and this is Coding Mitta.